So here we are, example 1b. Let's try and do this, or I'll try and do this one without making any mistakes. 7x plus 6y is equal to 5x minus 6. I can already see that these variable terms, plus 6 and minus 6, the value 6 is the same for both, so I don't need to do any multiplication to each, and I see that they're opposite to each other. So if I add these two equations together, positive 6 and a minus 6, they're going to cancel each other out. So addition is generally a little easier. I don't have to worry about carrying that negative sign through. So, you know, I'm not saying that you always have to try to do addition, but sometimes you can, and it's a little bit easier to work with. Okay? So now I go 7x plus 5x gives me 12x. I go 6y plus a negative 6y, or minus 6y, is 0y. And then I go 4 plus negative 28, which is going to be negative 24. The 0y term disappears, so I get 12x is equal to negative 24. I divide by 12. Whoa. Divide by 12. Divide by 12. There we go. Divide by 12. X is equal to negative 2. Then I take that value of x is negative 2, and I take that and I substitute that back into one of my original equations. 7x plus 6y. 7x plus 6y is equal to 4. Substitute in negative 2. And solve for that variable. This is minus 14, so I got to add 14 to get rid of it. Add 14 over here. I get 6y is equal to 18. And divide by 6. Y is equal to 3. So the solution to my system, negative 2, 3. Now, yes, of course, these are probably graphable, and you'd be able to find these two solutions fairly simple. But the whole idea is that we'll walk you through some steps of some easy examples so that you can get the idea. Right. So there's your solution, and of course if I wanted to check that, I would verify. Take that point, substitute it back into both equations. You can't just do one, you'd have to do both equations to see if it holds true. Okay? Because it could be true for one, but not true for the other. So if you're going to verify a system of equations, you need to go back to the original equations and substitute back in into both equations. Okay. Next example is a little bit longer, so I'm going to finish this one right here, and I'll come back with example number 2.